All right, so we're going to do some more examples. So here's our original function. So this function is the f of x, and they want us to do half of f of x. And so what that's going to be is a vertical compression of a half. They have a fraction in front of the function, so it's just going to scale it down a little bit. So what that means is I'm going to take all of the y values that are here and do half of them. So this one is up at 4. I'm going to take half of that and make it 2. This one's at 2. I'm going to make it 1. This one is up at 6. I'm going to make, 6. I'm going to make it 3. And this one's at 4, so I'm going to make it 2. And then I will connect these. And it looks similar, but it's been squashed a little bit. We're not worried so much about the fact that it looks like it moved down, because sometimes it does, sometimes it doesn't. It's more about it just not being as tall. So that's the 1/2 f of x. Okay, then if we come over to number 2, I have this -6 that's after the f of x. So that means it's going to move down 6 units. So I'm just going to take each point and go down 6 spaces. And so this one should look exactly the same. It's just been moved down. And they call that a translation. So on each of these, if they're just sliding it around, that's called a translation. All right, so on number 3, when I have x minus 4 inside the parentheses, that means it's going to move right forward, just looking at our last set of notes. So I'm just going to take this point, and this one's going to overlap a little bit. So while I'm teaching, I'm just going to use this colored pen. So this one goes right 4, this one goes right 4, this one goes right 4, and this one goes right 4. And so when we connect it, you can see that all the points go right 4. But sometimes if it starts touching the original graph or overlapping, it can get confusing. So a colored pencil sometimes helps. I'm just using a pen because it shows up best. Okay, so this one is a combination. So what I have is this -3 tells me it's going to go down 3. And the +2 that's inside the parentheses tells me it's going to go left 2. I always thought plus should be right, but it's just not how the math goes. So I'm going to go left 2 and down 3. So for each of these points, I got to do both of those. So from here, I'm going to go left 2 and down 3. Left 2 and down 3. Left 2 and down 3. Left 2 and down 3, like that. Wait. 2 and down 3. There we go. New point right there. And so you can see the whole thing has been shifted left 2 spaces and down 3 spaces to get to where it's at. I don't actually like having that, so I'm going to get rid of that. The whole thing just shifted over and down. So sometimes just knowing these rules by sight is a little easier than the other way. All right, so let's take a look at number 5. So if they put a negative in front of the f of x, in yesterday's notes we said that that was a reflection over the x-axis. So up here, this point is 4 points above the x-axis, so I'm going to flip it and make it a point 4 points below. This next point is 2 points above the x-axis, so I'm going to flip it and make it 2 points below. This one is 6 above, I'm going to make it 6 below. And this one's 4 above, so I'm going to make it 4 below. And we're going to connect those like that. So it should look like we took it and flipped it over. And then this last one on here, if the negative's on the inside, it should be a reflection over the y-axis. So this one's a little more exciting because it's going to overlap a little bit. So I'll just start with this point over here. So here's my y-axis, and it is 6 points left. So I'm going to flip it and make a point that's 6 points right. And then I'll go down to this point. So this point is 4 points to the left. I'm going to make it 4 points to the right. This one is right on the y-axis, so we're going to leave it there. And this last point is 2 points to the right, so I'm going to make a point 2 points to the left. And so when I reconnect this, it's going to overlap with the original. And it's kind of cool because it makes some symmetry when we're done. So the original function, part of it's still under there, like right here and right here. You can't see it very good, but then the new function that I did in pink kind of goes over the top of part of it. But it comes out about the same. Okay, so let's actually stop there.